Welcome to Module 31 in this series of lectures on statistical process improvement and statistical quality assurance. We've been talking about control charting and pretty much acting as if all one ever does with a control chart is to plot points, find limits, and see if points are inside of control limits. That's really not a completely accurate description of how these are used. In particular, it's important to look at control charts and see if one can see and interpret patterns on control charts, and that's the topic of this module and the next. Under stable process conditions, if one looks at a control chart, one expects to see essentially random scatter. One expect to see plotted cues that have no obvious pattern or trend, only on rare occasions falling outside of control limits, tending to cluster about the center line, typically equally above and below it, but on occasion reach almost to the control limits. If something other than this is seen, it's possible to get clues that as to what is going on physically that can be helpful in eliminating causes of physical variation, causes of systematic variation, and help reduce overall variation and improve process consistency. We're going to talk in this module about some terminology. Terminology is simply a set of names. What's really important is going from making a name to thinking about what kinds of causes could produce patterns of various kinds, and using that as a key or a clue to process understanding. One kind of thing is occasionally seen on a control chart are cycles, systematic variation, sort of up then back down again. Here's an example of such a thing. In this kind of a context, if one can figure out what is the period of variation, that period of variation can often give clues as to what stands behind the variation. This is a particularly simple kind of context where if this is hour, those up then back down again cycles happen every 24 hours. And what's going on potentially is is simply diurnal changes in ambient temperature. That possibly could cause changes in how production processes work, how chemical processes in particular work, and understanding the systematic cycle could lead one to either try to take mitigating measures or at least be aware that that things will change with time. Systematic variation like this is variation of the second kind. It may not always be economically feasible to eliminate it, but recognizing its presence at least allows one to consider options regarding remedial measures. The word instability is sometimes used to describe what is seen on a control chart. Instability is pictured in the second of these two plots on this panel. The first plot is absolutely what one expects to see on a control chart. On the one on the right, there are these occasional blips where it seems like something else is going on, and that could be just plain errors. It could be simply things that come and go on an erratic basis. And if one knows that that kind of pattern is there, there's some hope that one could think about, well, what went on at this time? What went on at that time? What went on at this time? And perhaps find some way to eliminate some kind of instability or erratic behavior. An important possible cause here of instability is something that should get mentioned in any discussion of control charting, and that's the possibility that one actually induces instability in a process by process over adjustment, by unwise tinkering with a process. Control charting is useful not only to tell one when something unusual has happened, but to give one reason to leave a process alone when there's no evidence of process change. One can make a process that looks like that start to look like one that looks like this simply by tinkering. If a measurement's a little high, then adjusting down. If a measurement's a little low, adjusting up, and pretty soon one has increased the amount of variation by over adjustment. So a useful word is instability. One can talk about changes in level on a control chart. Here's a picture where a plotted statistic has a decided change in level right there around 70 times 70. Sometimes that can be traceable to some kind of a basic change, perhaps an introduction of a new batch of raw material, a change in a machine, that kind of thing, and different suppliers providing parts, that kind of a possibility. The point is that if I know there's a change in level, a sudden change in level, I have a leg up on trying to figure out what its cause is and trying to eliminate it, thereby making the process more consistent. A gradual change of level might be one that starts at a low level and gradually moves up, or starts at a high level and gradually moves down. Worker training might do that kind of thing. A change in level might be gradual, where a change in level looks like it would pretty much go on unabated without intervention. You might call it a trend kind of thing that might produce a trend. Could be wear on a cutting tool in a machining process. As time goes on, the cutting tool wears down, parts get bigger, and here's a run chart where axle diameter as a function of part number or time increases in a trend fashion. Again, the point here is to have some language, but the language is only an aid in helping to think about causes and thereby eliminate causes and improve process consistency.